to talk about what all new things Flutter has announced in its Flutter Forward event. First two things which has really impressed me is first one is they have generate. So we had method channels, right? Whenever you want to communicate with native platforms, so they have something different which is still experimental. I'm not sure what exactly it is called. I think it is called as FFI Gen, but it makes working with native module APIs simpler. Like you I think you will of course you will still have to write Kotlin code or Swift code uh, whenever you want to access a native API, but it makes much more easier. And the second thing is Impeller, which is also still in experimental, and they had shown a demo of how Flutter is able to render 3D as well using that. So do check out the Flutter's YouTube channel for that. Now reading on with the documentation. What's next for Flutter? Setting out our vision at the Flutter Forward event in Nairobi. Today we are excited to share our vision of Flutter at Flutter Forward, our developer event streaming live from Nairobi, Kenya, as developers from all around the world gather in person and online to learn about future directions for Flutter. Flutter is a UI toolkit that enables app developers to build mobile, web, and desktop from a single code base. Flutter enables you to build, yeah, we already know all of this. Okay, so they have just released Flutter 3.7. So first is breakthrough graphics performance. Historically, cross-platform frameworks have required compromise on visuals due to the challenges of creating an abstraction layer. Flutter has taken a different approach than most, with its own rendering layer that offers hardware accelerated graphics and a consistent visual appearance on every device. Moving forward, we will invest in breakthrough graphics performance that extends Flutter's existing strength in this area. A Flutter Forward At Flutter Forward, we are showing more progress on Impeller, Flutter's next generation rendering engine. Impeller is optimized for Flutter, giving us more flexibility and control over the graphics pipeline and opening new opportunities for us. Impeller provides more predictable performance using pre-compiled shaders that elevate drop frames at runtime caused by shader compilation. It takes advantages of primitive in Metal and Vulkan, the modern low-level APIs in iOS and Android, and makes it effective use of concurrency, distributing distributing single frame workloads across threads. In addition to offering a silky smooth UI, Impeller can drastically improve performance in certain scenarios. One demo shown below demonstrate a best example of this. On this left uh, is a kaleidoscopic app using SVG clipping, build using the current default renderer. Scrolling down the page, performance drops with rendering taking longer than the pre-frame budget, leading to frame rate of 70 to 10 fps. The right shows the same app running under Impeller, rendering at glitch-free 60 fps. One advantage of building from the ground up is that the architecture can support brand new use cases. Newly introduced support for custom shader is already leading to some amazing new demos that show seamless integration with Flutter widget hierarchy. Our work here isn't limited to mobile device, though. We now have early support for custom shaders on the web too, with the same code now powering hardware accelerated experience across Android, iOS, and the browser. Now we are starting early work on supporting 3D with Flutter. During the keynote, we showed you that you can import models created with Blender and even use hot reload to iterate with Blender in real time. Yeah, this is really good. I don't think any game engine supports hot reload at this point. Maybe Flame, and that is only for 2D. I'm talking about 3D game engines. I don't think Unity, Unreal, or even Godot game engine supports hot reload. So this is very interesting, and see the results of a running app. It's early days, but we are excited about the initial performance we are getting, along with the potential of integrating 3D into other Flutter experiences. Adding 3D and custom shader raises the bar for graphics performance in a portable UI toolkit to a new level. We are excited to see what you do with this new feature as they become available. Seamless integration for web and mobile. While you can write an app entirely using Flutter and Dart, almost any non-trivial project needs to connect with other code. On the web, Flutter may be used as an embedded component within a larger app. On mobile apps, we need to call system APIs or other code written in another language. Our second major theme of investment is therefore seamless integration for web and mobile. On the web, we are previewing a new feature that we are calling element embedding, which allows further content to be added to any standard web div. When embedded in this way, Flutter just become a web component integrating cleanly with web DOM and even enabling the use of CSS selectors and transformation to style the parent Flutter object. We are also making big changes to the JS package to enable seamless interoperability between JavaScript and Dart code. With JS, you can annotate any function in your Dart code with JS, export attribute, and then call it from your JavaScript code. Combining these two new features open up some exciting new scenarios for using Flutter on the web. In a proof of concept demo that we showed at Flutter Forward, you can see a simple Flutter app embedded in HTML based web page. Using CSS, we applied an animated rotation effect even while the rotating the Flutter content remains interactive. The demo also shows that you can use an HTML button and JavaScript event handler to make changes to the Flutter state and vice versa. When this work is complete, we think this will open many new opportunities to use Flutter to add interactivity to an existing web app. Tuning to Android and iOS, Flutter has a long supported integration with system API using platform channel, which offers message-based approach for communicating with code written in a language like Kotlin or Swift. While this unlocks access to these libraries, it requires an app author to be conversant with multiple languages and requires a fair amount of boilerplate code. We are now starting to work on a new approach for system interoperability that allows library to be directly called. And iOS, we are building on our work on FFI and C interoperability, adding support for Swift and Objective-C libraries. On Android, we are using GNI Bridge to Jetpack libraries written in Kotlin with a new command that automatically creates binding for cross-language interoperation and converting data classes appropriately. When complete, we aspire that this work will enable a Flutter developer to call a Jetpack or iOS library without needing to use plugin or learn a different API syntax, as well as greatly easing the work for a plugin author. Check out our sample to learn more. Okay. I actually don't understand. Like, maybe I'm missing something, but how is it possible to call like Android steps repo? Like, this could be interesting. Like, if you don't have to write, I'm not sure whether we have to write native code or not. Oh, I think what it is doing is that maybe no, I'm actually not sure what exactly is happening. But honestly, this seems a little bit complicated to me as compared to writing Kotlin or Swift code. I'm not sure, but this could be interesting. Let's see whether they would deprecate method channels or not. I don't think they would deprecate method channels. Early to new man emerging architect thanks to Dart's broad support for wide range of process architectures as well as its highly optimized JavaScript compiler. Flutter can already run on a broad variety of devices and form factors, but with some exciting new options on the horizon. Our third theme is bringing early support to new and emerging architecture. WebAssembly has been growing in maturity as a platform neutral binary instruction format with growing support on modern browser. Excitingly, WebAssembly opens the web platform to other languages beyond JavaScript. Over the recent month, we have been collaborating with Chrome team and other WebAssembly partners to add early support for garbage collected languages like Dart. Okay, let's see which are the garbage collected languages. Yeah, anyways, I don't want to waste too much time on this. Okay, the new extension to WebAssembly is now supported with a flag in the latest development builds of Chrome. At Flutter Forward, we are unveiling early support for Flutter compilation to WebAssembly, which will enable further speed and size optimization for our web support. Another platform architecture that we are generating growing interest is RICV, an open standard instruction set architect designed for broad usage. The Android team recently gave a talk on their work to support RICV. Oh, I'm not sure what this is, but this could be interesting. What is RICV? Like, I don't even know how to pronounce it. Number of generation of risk architecture. Hmm. Anyways, we are happy to announce that Dart now support RISC-V as part of our journey to enable Flutter to run on RISC-V devices as they become available. Production RISC-V hardware is still in its infancy, but at Flutter Forward, we demonstrated our progress to date on the Clockwork by Dev Term Kit R1, a self-assembly portable terminal running Linux. We believe RSC support will be of particular interest for embedded scenarios where Flutter can provide a powerful UI toolkit for diverse set of needs. Continued focus on developer experience, foundational to everything we have described above, is we have described about is developer productivity, which has been a hallmark of Flutter since its inception, with features like stateful hot reload. Our fourth and final area of investment for future is continued focus on developer experience across both Flutter and Dart. At Flutter Forward, we are previewing some of our early work on some major new Dart language features that we hope demonstrate our commitment to tasteful evolution of the language. In our development channel, we now have early support for records and pattern, two new enhancements that work particularly well together. We are also formally announcing Dart 3, which is the culmination of our work to introduce sound null safety to the language. Dart 3 also removes other long deprecated features to further modernize the language. We have started publishing alpha quality builds of Dart 3 along with matching Flutter builds, enabling developer to test packages and apps. For more information on Dart 3, check out the separate blog post on the Dart channel. Alright. We are investing in the developer experience of Flutter as well as, of course, following on from the success of the casual game toolkit we announced at I/O last year. We are sharing the first version of our news toolkit, which accelerates mobile development for news publishers and other content providers who want to reach mobile users without having to design an app from scratch. It includes everything you need To build an article-centric app with navigation and search, authentication, ad integration, notification profile, and subscription while incorporating best practices from Google News Initiative research. We are today featuring three early adopters here in Africa who are building apps based on this toolkit, including Hespress, one of the largest news site in Morocco, Bold Sports, a popular the Nigerian sports site, and the Standard, the oldest newspaper in Kenya. Moving forward, we hope you share our excitement about where we are taking Flutter. Moving forward, we are continuing to heavily invest in the core developer experience while making some foundational improvements that pave the way of ourselves and others to build even more powerful experience with Flutter. This image summarizes our direction. Beyond our own development theme, it's gratifying to see how Flutter ecosystem continues to expand. Like Flutter Flow is a low-code builder for developing native mobile application, and Widgetbook, which provides flexible tooling for designers and developers to collaborate on user interface development. In closing, it has been wonderful to come to Kenya and see the entrepreneurship. Okay, introducing Dart 3 Alpha in December. Uh, in December, we gave a glimpse into the future with our first blog post discussing Dart 3 today live from Flutter Forward developer event in Nairobi, Kenya. We are sharing the broader vision for Dart's next major release and our first preview build, Dart 3 Alpha. Our mission for Dart is to create the best programming language for building high quality apps across any app platform. Dart is approachable, easy to learn, avoids unnecessary complexity, and is internally consistent. Dart is productive. App developers are under constant pressure to deliver apps with ever changing requirement in less time, yet with uncompromised quality and finish. So we build Dart with deep focus on enabling fast development, rapid iteration, and high quality. And Dart is portable, spanning the widest set of platforms to enable you to develop apps to the devices of today and tomorrow. We have worked on establishing this quality over many years. With Dart 3, we intend to take another big step, refining and expanding on approachability, productivity, and portability in significant way. Dart 3 is a major new release, partly to signify the large step forward in new functionality, and partly because it's breaking release in terms of semantic versioning. We are changing the type system to only support sound null safety in Dart 2.12, and later this was opt-in, and have made corresponding breaking changes in Dart's core library. Dart 3 productivity enhancements, a more expressive Dart language, records, pattern, and access control. We have evolved the Dart language at rapid pace the past few years, adding 23 new features since 2.0. In Dart 3, we expect to add two new major features, records and pattern, with the goal of making work with structured data more productive. Records allow you to efficiently and concisely create anonymous composite values from any existing data without the conceptual overhead of needing to declare a class to hold the values. With records, you can easily build new data structure that combine existing data, for example, to return a pair of values when records allow you to combine data pattern can destructure composite data. Like this is kind of like object destructure in JavaScript, right? Patterns are fully type safe and checked during development. You can also pattern match on the type of values, for example, from a hierarchy of classes, as which can use patterns that match on their type and the individual fields of each type, as in the body of calculate area here. Overall, we are adding a large section of patterns when combined makes Dart much more expressive for structured data. In conjunction with pattern, we are also adding capability controls to classes via several new modifiers. Interface class cannot be extended. Base class disables the implicit interface, so cannot be implemented. Final class cannot extend, implement, or mix in the class outside the current library. Sealed classes same as abstract plus final plus. The type is considered the root of a sealed type family for exhaustiveness checking. As an example, take the shape class hierarchy above. In switch statements on the shape type, like the calculate area function, the analyzer will trigger errors if the switch statement does not handle all possible subtypes of the sealed type. Mixin class, a class which may be used which may be used as a mixing. Every new features add complexity to the language. To ensure Dart remains approachable, classes default to be fully permissive just like today, with the small exception that classes intended to be used as mixins must now use the mixin keyword. Productive platform integration via direct platform library interop. We are working on expanded Dart language interoperability for calling platform libraries directly from Dart. On Apple platform, we are building on work on FFI for C interoperability, which supports calling any C module that follows the C calling convention from Dart. This has so far supported languages such as C, Go, and Rust. Now we are adding support for Swift and Objective-C on iOS and macOS. On Android, you can call into Jetpack libraries written in Kotlin and Android libraries written in Java by leveraging FFI and Android's Java native interface. Powered by new tool, Dart can automatically create bindings that have Dart interface, and behind those cross-language interop code based on the header interface files of the original C, Objective-C, Swift, Java, Kotlin code. For a demonstration of using this to call into Apple's Core Motion API and Android's Health Connect API, check out the sample app. This new interop mechanism are currently experimental, but we hope that they will reach at least beta quality in Dart 3.0 stable. Feedback is appreciated in the issue tracker for Java, Kotlin, or C, Objective-C, Swift. Finally, we are working on improving Dart to JavaScript interop. We'll have more news about that in a future blog post. Portability and advancements. Dart already supports a wide range of target platforms with our native and web compilers on the web. We currently compile to JavaScript on native devices. We currently support the Intel 32-bit and 64-bit and ARM 32-bit and 64-bit architecture. There are a number of emerging devices and standard we are working on adding support for to ensure Dart is ready for the devices of the future. For web, we are working on support for WebAssembly, which has been growing in maturity as a platform neutral binary instruction format across all modern browsers. It's our hope WASM can enable Dart web apps to start as fast as apps on native devices. Another platform architecture growing in interest is RISC. I know, yeah, we already saw that. Finally, we are working on expanding our current support for ARM devices to also encompass ARM64 support on Windows. With new Dart 3 capabilities covered, let's turn into the breaking changes we are making in the spirit of more consistent and approachable Dart. Introduce sound null safety in Dart 12. In sound typing system, you can trust the types, meaning a variable is never null when the type state that it isn't. This raises productivity by catching issues during development rather than in production, and enable Dart compilers to produce small and more optimized code. As we discussed in December, Dart is unique in introducing 100% sound null safety to an existing language. Since Dart 2.12, null safety has been configuration option that could either be on or off. In Dart 3, all code runs with sound null safety on. It is no longer possible to run apps without null safety or in mixed mode with partial null safety. We realize that discontinuing support for running without null safety can pose issues for existing apps and packages. However, we feel now is the right time to move forward with this change. Having a single type system where null safety is always on reduces overhead and complexity. Whenever developer reads a piece of Dart code, they can rest assured that all variables are non-null by default. On the implementation side, Dart compiler and runtime can focus on supporting a single way of running Dart code, which lowers the cost and complexity of adding new features. Dart ecosystem has demonstrated a strong dedication and willingness to migrate existing code to a null safety. As of today, 100% of the top support null safety still run without null safety. Thanks to the ecosystem. Okay, cleanup of Dart 3 core remains. We have made a number of breaking changes to for more details. See GitHub issues. Okay. So remove the historical syntax for default parameter values. With Dart 3 alpha done, our attention is now turned to Dart 3 beta. Where we hope to further refine the Dart code libraries by adding a number of new APIs. Preparing your code for Dart 3 stable. Most code has already migrated to use null safety. Dart 3 tools cleanup. Okay, discontinued deprecated core libraries API part 1. Okay, Dart convert mirrors. I think IO and convert I was using in my code. I don't know about this developer. Okay, what else? Dart web SQL. Why continue to publish it? Okay. Oh, in dot parse, double dot parse. Oh, this has been removed. List, use list dot field. What else I'm using? Dart HTML, I think I was using it. Postponed and not planned for inclusion in Dart 3. Dart core, I was, I think, using it. Async, I was using it. What else? Removing the colon syntax for default values. Okay, so that's it for today's video. We will see the next updates in the next video. Thank you for watching. Bye.